In this video, we will continue with the GP sums. So here also we have to show that the given progression is a GP. And then we have to find its first term, common ratio, nth term, and then seventh term. So what is my T1 here? 0.4, T2 is 0.8, T3 is 1.6. So how do you find out whether the progression is GP? We know that now. T2 upon T1 should be equal to T3 upon T2, right? So let's say T1 is 0.4. Okay, we have to calculate for T2. What is T2? 0.8 upon T1, which is 0.4. Point and point, this decimal will go 4 2s are. So my T2 by T1 is 2. So let me calculate T3 by T2, which is 1.6 upon 0.8. So decimal and decimal, this will go 8 2s are 16. So we have 2 here also. So the ratio is constant and it is 2. So the progression is a GP1. Now what is the first term of the progression? First term is always T1, which is A. So your A is 0.4. And common ratio you have found R is equal to 2. So first two parts of the question done. Now nth term. For nth term we know that Tn is equal to A R n minus 1. Right? So let's substitute the values now. A is 0.4, R is 2 raised to n minus 1. So, can I write this 4 as 4 by 10? Right? So that I can combine this 2 with the 2 that I will get here, 2 raised to n minus 1. So, Tn is equal to this I can write as 2 square, and in the denominator I can write this 10 as 5 into 2 into 2 raised to n minus 1. Now, if I bring this 2 up, what am I getting? I am getting Tn is equal to T square into 2 raised to n minus 1 into 2 raised to minus 1. So, in the denominator, I have only 5 now. Now, in the numerator, I have only 2's. When bases are same, powers are added when they are in multiplication. So what do I do? Tn is equal to 2 raised power 2 plus n minus 1 upon 5. Now minus 1 and minus 1 becomes minus 2. So Tn is equal to 2 raised to 2 minus 2 plus n. This and this will go and I will have 5 in the denominator. So my Tn is equal to 2 raised to n upon 5. Right? This is my nth term. Now using this nth term, I have to find the 7th term. Now how do I find T7? I will replace n by 7 over here. So 2 raised to 7 upon 5. So, okay, this is 7th term. So my T7 is equal to 2 raised to power 7 is 128 divided by 5. This is my answer. Now some different types of sums. Here we have to find which term of GP is 768, right? So last term here is given 768 and we have to find which term is this 768. Does that mean we have to calculate n here? Right? We have A as 3 and we have R as T2 by T1, that is 6 by 3, which is 2. So I got R as 2, A is 3, and last term, that is Tn, is given 768, right? So let me calculate this n. Tn is equal to A R n minus 1. Tn is given 768 is equal to A I have 3, R I have 2 whole raised to n minus 1. I can shift this 3 down here. What will I get? 768 upon 3 is equal to 2 raised to n minus 1. Now 3 2s are 6, 3 5s are 15, 3 6 are 18. So I got 256 is equal to 2n minus 1. So can I convert this in terms of 2? Yes. 2 raised to 8 is equal to 2 raised to n minus 1. Now, you know that if you have 2 on both sides here, when your bases are same, in the equation, you can compare the powers. So can I write 8 is equal to n minus 1? Shift this one here, 8 plus 1 equals 9. So you have calculated n as 9. So which term of this GP is 768? Ninth term. Right? Similar sum. Let's revise with this sum. Now, what is my A? Again, the same. Which term of GP is 640? That means my TN is 640. What is my A? First term, 5. What is my R? 10 by 5, which is 2. So, I will use the general term, which is A R raised to n minus 1. TN is given 640 equal to A is 5. R is 2 whole raised to n minus 1. Now 640 divided by 5 is equal to 2 raised to n minus 1. So 5 ones are 5, 5 2s are 10, 5 8s are 40. So I have got 128 is equal to 2 raised to n minus 1. Now can I convert this in terms of 2? Yes. So this will be 2 raised to 7 equal to 2 raised to n minus 1. When bases are same, you can compare the powers. So 7 is equal to n minus 1. Shift this n to this side, 1 to this side, you will get 7 plus 1 equal to n. So your n is equal to 8. So which term of GP is 640? You can say that 8th term of this GP is 640. Is this clear? Okay. Now, one more. This time we have the sequence given in form of irrational numbers. So, which term of this GP is 729? So now you can identify Tn as 729. What is my A? A is under root 3. What is my R? R is 3 upon under root 3. Right? So we cannot have root 3 in the denominator. We need to rationalize it. So this becomes 3 root 3 upon 3. 3 and 3 will go. So it is root 3. So you have calculated R as root 3. Now let's write Tn is equal to A R n minus 1. And we are going to calculate the value for n. What is my Tn? You are saying it's 729. What is my A? Root 3. And what is my R? It's root 3 n minus 1. So 729 is equal to, if you compare the roots here, root 3 into root 3 raised to n minus 1. Okay, bases are same. 729 we can write in terms of root 3 as root 3 whole raised to 12. Here we can get root 3 when bases are same, powers are added, minus 1 plus 1. This and this will go. So now you are left with root 3 raised to 12 is equal to root 3 raised to n. Bases are same. You can compare the powers, right? Oh, is it root 3 into... Oh, we did some mistake here. Where was this? Okay, this is root 3 into n minus 1. Okay. So we got root 3 whole raised to 12 is equal to root 3 whole raised to n. So your n is equal to 12. So 12th term 12th term will be 729. Fine.